Chapter 1, Section 2 lesson, so make sure you get these in your notes. So today we're going to talk about a different property. Exponents, right, mean that we multiply it by itself, repeated multiplication. So here I'm squaring, I am squaring 5 to the 5th, so that means I have 2a to the 5ths. 1, 2. Well, a to the 5th, remember exponents mean repeated multiplication, so a to the 5th means I have 5a's, and another a to the 5th means I have another 5a's. So then how many a's do I have together, because I'm multiplying those two? So go ahead and pause it and you can do these. Cubed means I have 3a cubes, 1, 2, 3, so then what would this be? And then a faster way to do it, what do I do with the 4 and the 5? How can I go about this? So when I take powers, 2 powers, what's the process? What's the rule? So you can try to come up with a rule. You can pause this if you want to and come up with it. So you can see this is a to the 10th. I have 10 a's because I have 2 5's, it's 10. So 5 plus 5 is 10, right? Or when we multiply by the same base, we add exponents. So 3 plus 3 plus 3 is 9. Well, there's a faster way. Instead of repeated addition, right? With my exponents, can I just do multiplication? 4 times 5 is 20. So whenever we have powers to powers, we multiply exponents. Powers to powers. Multiply exponents. So powers to powers. So we got to know the difference between when it's a power to a power and when it's multiplying by the same base. So notice that there is only one base here, where when we have 2 bases, we add exponents. But when I have 1 base and I have exponent to exponent, I multiply my exponents. So here's the next section. So section 2, so there's chapter 1, section 2, so 1.1, you can highlight that. So here's the rules: powers to powers, multiply the exponents, in just kind of generic form. Here's some examples. All right, so you can pause that and write it down if you don't have it in your notes already. Okay, so here's the first example. Go ahead and highlight that. And then here we go. So how do I simplify this? I have an exponent of 4 and an exponent of 7, and I'm raising a power to a power. So I just multiply my exponents. So n to the 28th. Go ahead and highlight that. So here's another type of example. Here we have another exponent raised to another exponent with 1 base. So power to power, we're going to multiply our exponents. So 2/3 times a half. So this is multiplying fractions, and when we multiply fractions, just multiply straight across. Or you can go ahead and see if you can cross cancel with multiplication. You can cross cancel, because really I could rewrite that as 1/3 times 2 over 2, and 2 over 2 is 1. They would cancel, right? So I'd get x to the 1/3. Or you can multiply straight across. I'd get 2 over 6, and then you can reduce that by 2, and you get 1/3. So highlight that, x to the 1/3. Okay, so here's an example. You can pause the video and you can do that on your own. P to the 5th raised to the 4th. So exponent raised to exponent, multiply. Okay, here's another one, so a little bit more. Next type. Go ahead and get that down, highlight it. So now we have multiple bases, okay? This base of y has an exponent and it's being raised to an exponent. So those are the two that we're going to multiply. So y raised to the 5 halves multiplied by -2. Whenever you just have just a whole number right there, it's always over 1. So you can put it over 1. Now we can go ahead and multiply straight across. Or we can cross cancel because there's 2 2's in there. But I won't for now. So -10 over 2, which reduces down to y to the -5, right? -10 divided by 2 is -5. Now I still have this y cubed out front. And then I'm multiplying, right? Outside the parentheses, multiplication. So this is multiplication. Now when I multiply by the same base, so now you see that we have 2 bases, but they are the same, and we're multiplying, so that means we can add these. 3 plus a -5 is y to the -2. Highlight that answer. So powers to powers, we multiply, but when we multiply by the same base, we add. Okay, so try to remember the difference there. Okay, so here's a good one to practice on your own. You can go ahead and do it on your own. And go ahead and pause the video and you can go ahead and do it. So this one's going to be x to the negative 22 would be the answer. Okay, so here's a little thrown in one. So this kind of expanded, right? So now when I have a constant out here, so this is multiplication in between here, and this whole thing is being raised to an exponent. Okay, so remember exponents means there's multiple of them, so I have 4m to the 1/2. I have 3 of them. That's what the cube means, right? That means I have 3 of these. Well, just like we done a couple days ago, whenever we have these coefficients, multiples of them, I have 4 of them, right? So instead of writing 4 times 4 times 4, I can write 4 to the 3rd. And then I have 1/2. Well, when I multiply by the same base, don't I add exponents? So I'd be adding all these exponents. Half plus a half plus a half is 3 halves. Literally, I have 3 halves, 1/2, 2 halves, 3 halves. And now I can go ahead and do this. 4 to the 3rd is 4 times 4 times 4, which is going to be 64. And then this one would be still 3 halves. So that's kind of expanded. So this 3, when I'm multiplying, big thing is multiplying in here, that 3 can go to the 4, and it goes as an exponent. What's the exponent of 4 right now? It is a 1. So 3 times 1 is 3, and then 3 times a half is 3 halves. So that last example is a product because we are multiplying 4 times m to the 1/2. We are multiplying here and raising that multiplication, what is called the product, to a power of 3. So there's the property here and some examples. So you can pause that and get that down. So here's the next problem. So again, it's product. This time it's product raised to a power. Okay, and so one side, this length right here is 5x cubed, and it's a square, so that means all these sides, these 4 sides are 5x cubed. And we want to find area. Well, area of a square is just one side and square it, right? So I want to take 5x cubed and square it, which means I have 2 5x cubes. So this is an expanded version, 5x cubed times 5x cubed. So which is 5 times 5, which is 5 squared, right? Which means I took that 5, this 2, and went to the exponents, to both of them. This would mean I have x to the 6, right? 25x to the 6. So those exponents go to exponents, and we have a product in there. Okay, here's one you can pause on your own. Go and do it yourself. I'm going to write down the answer right now, so if you haven't done it, you need to pause it. So it'd be 7 cubed m to the 9 times 3. It's really, remember that 7 does have a 1 as an exponent, so really it's 1 times 3. So that's where we get the 7 cubed, and this is 27, and 7 cubed is 7 times 7 times 7, which I think is 243. I don't know, whatever 7 times 49 is. It is not 243, it is 343. Okay. Okay, now it's a little bit, now we're adding, so we're continually adding and adding more property. So here we're now adding power to power as well as product to power. And from our very first one, when we multiply by the same base, we add exponents. So now we're throwing in the 3 different properties we've learned so far. So you can just do one at a time. So you can start with this first. We have exponent raised to exponent, so we multiply. So that's 1/2 times 10. So that is 10 over 2, which is 5. So end of the 5th. Now I do the product one. So that means this 3 is going to go to all 3 exponents. This 1 is an exponent, this 1 is an exponent, and the negative 2/3 is an exponent. So I'll put this in parentheses. So we have 4 to the 3, m to the 3, and to the negative 2/3 times 3. These 3 will cancel because there's a 1 underneath here. So we can cross cancel. So we get 4 cubed, which is 4 times 4 times 4, which is 64. And we get m3 and then 2 to the negative n to the negative 2. Now notice that my n's, I'm multiplying here. Anything outside the parentheses, multiplication. we got two ends that are the same, so we can go ahead and add those exponents, right? My exponents right here is 5, right? So I got 5, I got another n to the negative 2. So we can go ahead and add those. So we get n to the third. We have m to the third as well, and then 4 cubed, which I said before, is 64. So go ahead and highlight that answer. Okay, here where you can pause the video and try this one on your own. Okay, I'm about to do it. Go exponent, exponent, so x to the negative 4th. Product to a power, I'm going to distribute that to the exponent, so 3 to the 4th, x to the 4th, and then we go ahead and multiply 5 times 4 there as exponents. So I'm multiplying exponents, not my constants, or my coefficients, so that 3 just stays a 3. And then 4 to the third is, that's 243. And so then these x's are also the same base, so we add those, so we get x to the 0, y to the 20, and 243. And so now what we can do, x to the 0, we can leave it as x to the 0, or literally we don't have to write any x's if we don't want to. 3 to the 4 is not 243, that's to the 5th. It is 81. So I can write 81, no x's, y20. So that's kind of like simplified form. Okay, so here's the last one, hardest one. So it's putting it all together, but it's doing it in scientific notation. Right, so scientific notation, we have this equation here, half of our mass times velocity squared. And so it's going to give us our mass right here. Mass is 1.3 times 10 to the third. And then our velocity that gives us our speed is right here. So we're plugging in that equation, 1/2 m times v. And this ms at the end is just units, our units. This kg is units. Those aren't our variables. Okay, so they're not in the equation. So we multiply here. Well, we can just multiply 1/2, which is 0.5, right? And times 1.3 times 3.1. And so we get 2.015. So that's in scientific notation, right? Because it's from between 1 and 10. And now we can go ahead. We have our same base here. So we can just add those because we're multiplying all the way across. So times 10 to the 6. So there is our answer. Okay, go ahead and try this one. Go ahead and try this one, same formula. And this time you have a new mass and you have a new velocity. So go ahead and pause the video and do this. So 1/2, which is 0.5. 2.5 is my mass times 10 to the 5th. And 3 times 10 to the 2nd is my velocity. So I'm going to multiply 2.5 times 3 times 0.5. See what that is. That's 3.75. So that is in scientific notation because it's between 1 and 10, and then I add my. So there, that's that one. All right, that's it for that.